Hello. We are going to be starting our chapter on alcohols, ethers, phenols, and thiols. So let us begin by introducing our new functional groups so that you can learn to identify them in organic molecules. We will also talk about our different isomers. So our new functional groups include alcohols, which have a carbon atom bonded to an OH group. So we have to remember that this R here is a carbon something. So it just means the rest of the molecule. But that means that the OH has to be attached to a carbon. Carbon something. An ether contains two alkyl groups. That means two carbon something or others, whereas the alcohol only had one. A thiol is a lot like an alcohol, only it contains sulfur instead of oxygen. Oxygen and sulfur are in the same group on the periodic table, so they have the same number of valence electrons. You can see their bonding pattern is very similar. Both have two single bonds and two lone pairs. Two single bonds and two lone pairs. So alcohols and thiols. There's also phenols in this chapter. Phenols have an aromatic ring. We know that this ring is aromatic because of the alternating double and single bond pattern within the ring. Here's some examples of ethers and alcohols in everyday compounds. So in a molecule responsible for the smell of coffee, there's an ether and a thiol. In menthol, menthol is used in like cough drops and stuff, Vicks Vapor Rub, that type of stuff. Menthol has an alcohol group. Urushiol has a phenol. This is kind of a double phenol happening. So either circle would identify a phenol. Urushiol is the compound that's responsible for poison oak, poison ivy type of rashes. Thiols are also responsible for the smells in onions, garlic, rotten eggs, and skunks. They are stinky compounds. So in this molecule that's responsible for onions, you can see the thiol group here. And then for garlic, you can see the thiol. You can see that the structure between the onion molecule and the garlic molecule is the presence of this alkene group here. Both have 3 carbons, but this one is a alkene group, and that one's just single bonds. Methane thiol is the compound that you all recognize as the smell of a gas leak, like your natural gas in your house. That compound, methane is normally scentless, and so the addition of methane thiol allows us to smell in order to easily detect when there is a gas leak. Then these are the compounds responsible for skunk smells, and you can see that there's a thiol group on both ends, on each of these molecules. Let's practice classifying this molecule. Go ahead and pause the video and identify what functional group you see in this molecule. Unpause the video when you're ready to check your answer. Okay. This molecule is an alcohol. That's because this ring is not aromatic. We can tell it's not aromatic because it's all the single bonds. So this is an alcohol, not a phenol. Phenol you'd either look for alternating double bonds or a circle, which indicates that it's aromatic. Let's also practice drawing some structures for alcohols. Go ahead and pause the video and try to draw a line angle structure for this alcohol and the condensed structural formula for this other molecule. Unpause the video when you're ready to check your work. Okay, so our first molecule has 3 carbons, and so to draw our line structure, we will draw 3 carbons. It doesn't matter whether you go up first or down first, just draw 3 carbons. Now when you go for an OH group, you have to remember that's a carbon right here, so we can't write OH because then we won't see the carbon. So you have to draw out again to say OH. You can think that we're trying to follow the angles of a hexagon. So just kind of imagine, there's hexagon graph paper available on Canvas so that you can practice getting your angles good. But this has 3 carbons and an OH group. Now we have to draw the condensed structural formula for this one. There are 1, 2, 3, 4, 5, 6 carbons. The ones on the end are going to need 3 hydrogens each in order to have 4 bonds total. These ones in the middle are going to have 2 carbons each because there's 2 single bonds coming out of each one already. And then this one here, we have to remember that there's 1, 2, 3 bonds, and so that one's only a CH, and then it has an OH as its 4th group. It has 3 other carbons on it. So let's see, we got CH3, CH, and you can write the OH in parentheses, CH2, 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 CH3. You could also merge those together if you like, or you could draw the OH going down. Either way is okay. You have options with the condensed structural formula. Any of those are correct, or a combination of features. It's all good. There are different isomers possible. Last week we did talk about our different constitutional isomers, but now we're going to subdivide that constitutional isomers into subcategories, because now we have to differentiate between whether it's a difference in the carbon chain and how the carbon chain is connected, or if it's a difference in where the functional group is. So skeletal isomers, that font color does not show up well. Skeletal isomers have a different carbon skeleton. That means that the carbon atoms are bonded differently. So if we look at these different pairs of molecules, we can see here that the arrangement of carbons here is different than the arrangement of carbons here. And so this pair of molecules are skeletal isomers. When we identify what type of isomers we have, we're really talking about the relationship between different molecules. So we're saying that the relationship between this molecule and this molecule is that they are skeletal isomers. That tells us that the bonding arrangement of the carbons is different. If we look at these 2 molecules, 1-pentanol and 2-pentanol, we can see that the arrangement of the carbon atoms is the same. The difference is where the OH group is connected. And so the relationship between these 2 molecules are positional isomers. Positional isomers have the same functional group, meaning they're both alcohols, but the alcohols are located in different positions. We can also see that the relationship between 3-pentanol and 2-pentanol is that those are also positional isomers. This one has a different, if we look at those two molecules, these do have the same carbon skeleton, but the OH is in different spot, and so this pair is also positional isomers. The more carbon atoms you have, the more options there are for isomers. There's another type of constitutional isomer called functional group isomer. So functional group isomers have different functional groups. And alcohols and ethers can be functional group isomers. So we can see here that this is an ether and this is an alcohol. So these are different functional groups, and so these are functional group isomers. We can see that both have 6 carbons. 1, 2, 3, 4, 5, 6. Both have 1 oxygen. And then they have 2, 4, 6, 8 plus 6 is 14. 2, 4, 6, 8, 10, 13, 14. So both are C6H14O, but one's an ether and one's an alcohol.